Professor, there must be so much advanced technology behind Japan's effective reduction of fluorinated gases that can be helpful for worldwide reductions. Could you tell me about this technology and approach to non-fluorocarbon techniques?
This graph shows the change in emissions of HFCs, PFCs, and SF6.
These 8 categories are the same as the 8 sectors of the 22 business organizations that established the Voluntary Action Plan, aren't they?
Right, Tomoko-san. And the sectors which have made especially large reductions are HFC and other gas production, cleaning and solvents, and electrical insulation gas. Let's start with these 3 sectors. First, let's look at HFC and other gas production. HCFC22 was used as a refrigerant for air conditioners, and it is now a primary feedstock for fluorinated resin used for cooking pans and fluorinated plastic materials, which are used for waterproofing, such as on the dome of a football stadium. In the production process of HCFC22, HFC23 occurs as a byproduct. This substance has a very high greenhouse effect, 11,700 times higher than CO2. Japan developed the technology to destroy HFC23 and reuse fluorine. In this process, HFC23 is separated from byproducts and destructed at a high temperature. Decomposed fluorine can be used as a material ingredient again. This type of equipment, due to its low output of byproducts and exceptional process management, has made it possible to realize a large-scale reduction of greenhouse gas emissions of HFCs. And in the HFC production industry, a voluntary action plan was adopted to introduce this HFC23 destruction facility into all the gas plants. This same technology is also utilized in the CDM, or Clean Development Mechanism, which is one of the Kyoto mechanisms set in the Kyoto Protocol to encourage cooperation on greenhouse gas reductions in developing countries.
Already, this is recognized as technology of global importance.
Next, we have the cleaning of machinery parts. From the Montreal Protocol era, Japan's cleaning technology contributed to a large reduction of fluorocarbon usage. Japan has the world's leading cleaning technology, which is not only environmentally friendly, but also cost-effective and safe for human beings.
Cost-effectiveness is appealing for industries. CFC cleaning agents had been phased out completely in advanced countries in 1995, according to the Montreal Protocol. However, the phase-out in developing countries isn't targeted for completion until 2010.
Yes, 20 years ago, it was safe and convenient to use fluorocarbons such as CFC 113 or chloric solvents such as 1,1,1-trichloroethane, which deplete the ozone layer. These materials were used in massive quantities for cleaning circuit boards or precision machinery parts. One of the alternative cleaning techniques is a vacuum hydrocarbon agent cleaner. By sealing up the cleaning process, it prevents any leakage of solvent and also reduces the use of detergents by up to 1/5. As for cleaning techniques without the use of fluorocarbons, for most purposes, solvents are converted to aqueous and semi-aqueous agents, hydrocarbons. However, there have been several problems, such as drying time, drying stains, running costs, greenhouse effects, and VOC problems. This machine solved all these problems. This is unprecedented technology that can't be found in any other country. People from all around the world come to Japan to observe this technology.
In the field of cleaning, Japan has the experience in various methods ranging from fluorocarbon to non-fluorocarbon use. That's why Japan can provide technical support to developing countries.
Next, we have the electric insulation gas Sf6. In a country with a limited area of land like Japan, this is an essential material for the supply of electricity because Sf6 allows us to build underground substations. At a power plant or substation, electrical equipment such as gas insulated switchgear are filled with SF6 as an insulation gas. SF6 has ideal characteristics for insulation, high dielectric strength, and safety. SF6 does not deplete the ozone layer, but it does have a high GWP, or global warming potential rate, at 23,900. This equipment is perfectly sealed using the most advanced techniques, so that there is virtually no leakage of SF6. Also, there are certain measures in place to prevent the release of SF6 into the atmosphere. These measures include the use of gas recovery equipment to recover SF6 before maintenance and at the end of its usage.
So Japan's advanced technology allows us to utilize SF6 without adding to global warming. Are there any other uses for SF6?
Well, it's also used as a cover gas for magnesium casting. Magnesium is used in automobile and cellular phone parts, and is practically the lightest metal material. It is considered one of the most effective materials for combating global warming and saving energy because of its light weight and excellent strength. As a global warming measure in producing magnesium, we have reduced the usage of SF6 and developed non-fluorinated gases as alternatives to SF6. In Japan, non-fluorinated gases are being developed, such as 1234Ze with a GWP of 9, which can reduce global warming effects drastically. If all of the SF6 gas were replaced by these gases, we could expect to eliminate around 6 million CO2 tons of fluorinated gases. This company owns the world's largest die-cast machine. In 2007, they completely replaced SF6 with the non-fluorinated gas 1234Ze. Now they are manufacturing oil pans for automobiles and covers for motorcycles. 1234Ze is a safer alternative to fluorocarbon than sulfur dioxide, which is used in the US, Europe, and other countries. Nitrogen can be used as a diluted gas, also helping to reduce greenhouse gases. PFC gases are used in the process of manufacturing liquid crystals or semiconductors. PFC is one of the Kyoto Protocol gases that needs to be reduced, so liquid crystal or semiconductor factories are equipped with PFC abatement equipment to reduce PFC emissions. Liquid crystals and semiconductors are mainly manufactured in Japan, Korea, and Taiwan. This means there's little PFC emissions in the US and Europe. So Japan is taking the lead in worldwide reduction of PFC emissions. For your information, Korea and Taiwan are not obligated by the Kyoto Protocol. Next is foam products. They are used for thermal insulation in ceilings, walls, and floors, and also in various packaging materials and construction site products. Foam insulation helps to save energy by keeping air conditioning more efficient. Thermal insulation includes extruded polystyrene foam, urethane foam, phenolic foam, and high-expanded polyethylene foam. Formerly, fluorocarbons were used as a blowing agent for thermal insulation materials. However, prefabricated board and panel products and shaped products are no longer blown with fluorocarbons, and this has made a contribution to reducing greenhouse gases. In 2005, all extruded polystyrene foam and phenolic foam, mainly used as thermal insulation in buildings, became totally free of fluorocarbons. Progress is also being made in achieving non-fluorocarbon production of high-expanded polyethylene foam, a material used as thermal insulation for pipe covers in areas such as hot water piping and ducts, due to its flexibility, as well as for hard urethane foam, which also has a wide range of applications outside the construction sector. The thermal insulation used in domestic refrigerators is already free of fluorocarbons. Compared with 1989 shipment-based data, a reduction of 180 million tons of CO2 has been attained, and a reduction of 95% in the use of fluorocarbons has been achieved in CO2 equivalent. Conventionally, it has been difficult to switch to non-fluorocarbon foam for on-site spraying of urethane foam due to problems relating to safety and performance. However, now a non-fluorocarbon foam has been developed using carbon dioxide gas and water, and this technology is being eagerly promoted. In order to bring non-fluorocarbon products into more general use, Japanese Industrial Standards, or JIS, has standardized non-fluorocarbon thermal insulation. The government is taking the initiative in this project by requiring non-fluorocarbon thermal insulation in standard specifications for public works, and by introducing a law on promoting green purchasing to encourage the use of fluorocarbon-free products. This is a construction site for a condominium. Here, they are using a non-fluorocarbon foaming product that uses water. A chemical reaction with water creates carbon dioxide as a foaming agent. The benefit of this system is that you can use existing equipment, the same equipment that used to use fluorocarbons. Another method uses some special forms of carbon dioxide itself. In Japan, such technology allows foaming to be done even at temperatures below the freezing point, at which it is considered to be difficult to blow neatly.
You mentioned that insulating foam used for domestic refrigerators are now fluorocarbon-free.
Yes, Tomoko-san. Domestic use refrigerators in our homes have all been converted within a very short period of time to non-fluorocarbon, not only the insulator material, but also the refrigerants. At the same time, they incorporate a unique top-runner approach of saving energy, where the best efficiencies in industries become a standard for primary electric machinery. In Japan, isobutane is used as a refrigerant instead of fluorocarbon refrigerants. Isobutane is flammable, and so there are many precautions taken to prevent accidents. For instance, refrigerator piping, which used to be welded, has been changed to a seamless pipe to prevent gas leakages. Moreover, defroster heaters, which used to be in single-layer tubes, are now in double-layer tubes, so that surface temperatures never get higher than the combustion point. These forward technologies support the use of non-fluorocarbon. For other refrigeration equipment, such as convenience store showcases, non-fluorocarbon products using carbon dioxide are already in practical use. Also, non-fluorocarbon, energy-efficient automatic vending machines are now in use on the street all over this country. Most of these non-fluorocarbon equipment have only recently been put to practical use, so they are not widespread yet. However, the government is promoting the technical development and installation of non-fluorocarbon facilities and equipment with financial incentives.
Isn't there a law that obligates the recovery of fluorocarbons from home appliances like refrigerators and air conditioners?
Yes, Tomoko-san. There is a law that aims for the recovery of fluorocarbons to prevent them from being released into the atmosphere. When you dispose of home appliances, consumers should ask home appliance retailers to transport them. From home appliance retailers, the unwanted appliances are collected at a collection depot and then transported to a recycling center. At the recycling center, fluorocarbon refrigerant is recovered from residential air conditioners and refrigerators. When they crush the refrigerators, fluorocarbons from urethane foam are also recovered. Refrigerant fluorocarbon recovery volume measurement system is in place at the recycling center to record the weight of the recovery tank at all times. If anything unusual should occur, an alarm will go off in the system, and the recovery equipment will stop automatically. Recovered fluorocarbon tanks are equipped with fluorocarbon sensors to make sure everything is under control while in storage. Regarding commercial refrigeration and air conditioning equipment, such as building air conditioning, food showcases, commercial freezers and refrigeration equipment, and cold storage warehouses, fluorocarbon is recovered based on the Fluorocarbon's Recovery and Destruction Law. Based on this law, a new system was introduced to control the handing over of fluorocarbons using process manifest developed and provided by INFRAP. When commercial refrigeration equipment is scrapped due to building demolition or renovation, the construction company undertaking this work determines the equipment containing fluorocarbons and submits a process manifest to explain it to the owner of the building. The owner of the building then commissions the construction company to recover the fluorocarbons. The construction company submits the process manifest on fluorocarbons to the recovery company and requests the recovery. On receipt of this request, the fluorocarbon recovery firm goes to work and then submits a process certificate to the owner of the building. In this way, control of fluorocarbons from commercial refrigeration equipment is effectively implemented and secure recovery is achieved.
Professor, refrigerant used in mobile air conditioners is also required to be recovered, isn't it?
Regarding mobile air conditioners, based on the law for recycling of end of vehicles, when automobiles are scrapped, the fluorocarbons are recovered and a wide range of components and materials are also recycled. Through these kinds of systems, the fluorocarbon recovery rate in Japan is increasing year by year, and release of fluorocarbons into the atmosphere is being reduced. Also, emissions have been reduced by decreasing the volume of refrigerant used and preventing leakage with airtight seals. Furnace brazing is a process used in the production of mobile air conditioners to prevent leakage of fluorocarbons from the joints of parts. Brazing is a cutting-edge technology using heat up to 600 degrees Celsius to melt braze and apply it to the very small gaps, measuring less than 0.1 millimeters, found at the joints. When brazing is finished, leak tests are conducted using helium. When parts are joined with O-ring attachments, the visualizer finds the position to attach. Then a robot will attach them. Also, with improved performance and more compact sizes, the amount of refrigerants needed is decreasing. For fuel cell vehicles with heat pump mobile air conditioners, carbon dioxide refrigerant is already in practical use. Japan is the world's frontrunner in this kind of development.
Amazing, Professor. What else?
There are a variety of aerosol products, including dusters, insect repellents, deodorants, and industrial lubricants. Now, consumer aerosols are non-fluorocarbon, with the exception of dust removers and medical aerosols or other special-purpose products. If we compare it to 1989, 73 million CO2 tons of greenhouse gases have been reduced. LPG, or dimethyl ether, is used as an alternative substance. For dusters that use flammable gas, such as dimethyl ether, cautious use is necessary. To reduce the volume of emissions from dust removers while keeping them safe at the same time, using new gases with a lower greenhouse effect, such as carbon dioxide, or introducing mechanical blowers may become the solution.
It's been about 20 years since Japan started fluorinated gases regulation for protection of the ozone layer. Now I understand how Japan could reduce its output of fluorinated gases by 860 million CO2 tons. Japan's state-of-the-art technology enables us to make not only high-quality, cost-effective products, but products that are friendly to the environment, beneficial to the economy, and safe to humans.
These are only a few examples of what Japan has done to reduce emissions. You can check our brochure for other technologies and topics we didn't have time to introduce to you today. Please refer to our literature and ask us any questions you might have.
The technology and teamwork of Japan can be a hint to the world to reduce greenhouse gases. We can seek for economical, sustainable growth, safe and clean lifestyle based on advancing technologies on a global scale, while improving the protection of the environment of this planet that we live on.